All right, let's get started. Welcome everyone to this session about scaling your generative AI workloads with efficient model choice. My name is Simone and I'm a senior solution architect at AWS, and today with me is Martin, a principal researcher at Dynatrace. So this is our agenda for today. We will start with a customer challenge, which is selecting the best model for your use case, and then we will see 3 steps to achieve that, including identifying candidate models, evaluating them with your data, and then optimizing them for production. So generative AI has evolved quickly in a very short amount of time. In 2023, customers focused on proof of concept, in 2024 on production, and in 2025 on gathering business value. If we look into the future, more than 80% of companies will deploy generative AI APIs or applications by the end of next year. And Amazon Bedrock is the service that you need for your generative AI journey. It comes with 5 key components, all you need to build, deploy, and scale your generative AI applications. It allows you to choose the best models, to optimize them for cost, latency, and accuracy, and then to customize them with your data. After, you can apply safety and responsible AI checks, and then you can deploy AI agents to increase and extend the capabilities of your application. However, a challenge that you could face when building your AI application is to find the one model that optimizes for 3 dimensions: cost, speed, and quality of responses. Performance models, for example, Claude Opus or Amazon Nova Premier, provide very high quality of responses, but can be costly. On the other side, smaller models such as Claude Haiku or Amazon Nova Lite, they are very cost-effective and fast, but they usually don't match the quality of responses of the larger models. So you could struggle to find one model that optimizes all these 3 dimensions. Therefore, your choice usually becomes a trade-off. For example, for insurance claim processing, you want a model that optimizes for quality of responses with a trade-off on cost and speed. On the other side, for customer service chat routing, you need to optimize for cost and speed because you're handling large volume of data with a trade-off on quality of responses. And today, to help you navigate those choices, we will present a model selection framework which is composed by 3 steps. The first one is identify, where you define your use case and you come up with 3 to 5 candidate models. And then this is followed by evaluate, where you compare the performance of these models using your data. And using your data here is very important because different models behave differently on different use cases. And then this is followed by the optimize step, which is optional. And in this step, you can optionally tune your model for production. For example, let's assume you are a financial service company and you want to build a virtual assistant that helps your customer find your products. So here what you could do in the optimize step is to tune a model based on your own product documentation and customer interaction data to achieve this performance in the best way. Okay, let's get started with the first step, which is identify. As mentioned before, the goal of this step is for you to come up with 3 to 5 candidate models. And to do that, we will see how this step can be performed. So let's dive into that. So your starting point here is Amazon Bedrock, where you find the broadest selection of AI models from leading companies, including Anthropic, Meta, and DeepSeek. And the list here continues to grow. Here, analyze the offering of each provider and focus on the ones that make more sense for your use case. For example, for complex reasoning, focus on Anthropic or DeepSeek models. For multimodality, for example, the generation of images, consider Amazon or Meta models. And then, for long context tasks, like the summarization of entire books, consider AI 21 Labs models from the Jamba family. And then, within each provider, find the models that best fit your use case. For example, this slide shows the models within the Amazon Nova family. Now, if you need fast models, focus on Nova Micro or Nova Lite. If you need quality of response for very complex tasks, focus on Amazon Nova Premier. And for something in between that offers a good trade-off on all the 3 dimensions that we mentioned before, consider Amazon Nova Pro. Also, for generating images and videos, don't forget about Amazon Nova Canvas and Amazon Nova Reel. And these 2 models bring me to the next topic, modality. So when defining your use case, define the modality that you need and filter candidate models accordingly. For example, for customer support chat summarization, you need to summarize text into text, so just choose a text-to-text model. For insurance claim processing, you need models that understand input text, images, and potentially videos. For customer service over the phone, you need models that support voice-to-voice modality, so they can talk in real time with your customers. And here you can choose models like Amazon Nova Sonic that support this. And then filter the models by the differentiating capabilities that you need. For example, for complex math or reasoning problems, consider reasoning models. For autonomous tasks, including the invocation of external tools, consider agentic models. And then, if you need to customize models with your data, then choose models that excel at that, like Amazon Nova, Anthropic Claude, or open source models, including MetaLlama. And actually, you may also need models that excel in a specific use case. For example, medical knowledge, coding, or language translation. And for all these use cases, we see more and more demand because customers are building increasingly specialized solutions. For example, the summarization of Japanese text in the manufacturing industry, or the processing of financial reports for research analysts, or other use cases. Now, for all these use cases, you need domain-specific models that perform very well in a specific domain. And to meet these customer needs, we have released the Amazon Bedrock Marketplace, which extends the selection of Amazon Bedrock models with more than 100 additional models from more than 30 providers. So in the Amazon Bedrock Marketplace, you can find publicly accessible models such as Falcon, Gemma, and QN, and also specialized models, for example, upstage models for language translation, or evolutionary scale models for generating new proteins. And this list continues to grow. Now, these models from the Amazon Bedrock Marketplace can be accessed through the Bedrock Standards APIs. And for those models that are compatible with the Converse API of Amazon Bedrock, you can also use them with additional Bedrock capabilities, including agents, knowledge bases, and guardrails. Okay, the best way to see how the Amazon Bedrock Marketplace works is through a demo. I'm in the AWS console, and I choose Amazon Bedrock. Here, from the left menu, I choose Marketplace Model Deployment. So I want to find Marketplace models, so I choose View Model Catalog. And here I filter for Marketplace models only. So you can see the list has more than 100 models. Now, I want to find the medical model, so I enter the keyword medical, and as you can see, I get 3 medical models. So that's nice. Okay, let's try to change the search, and I now want to search for QN3 because I read about this model a lot on the internet, and I want to experiment with that. So as you can see, there are different variations of the same model, and I pick the one with least amount of parameters because I want the fastest response at the lowest cost. Here, I see the model page, and I can choose Deploy to deploy it in Amazon Bedrock. I keep all the parameters at default, and I choose Deploy to start the deployment. Here, after some time, my managed deployment will move from creating to in service. So at this point, I can start chatting with the model and using the model. So I choose the model page, and I choose Open in Playground to start chatting with it. And then I select the model again, and I choose Continue to open the chat interface. So here I can ask a question to the model. And my question is the following. Nothing to avoid reasoning. And then, who invented the word first airplane? Answer in maximum 10 words. So as you see, the model will now answer very fast because it's a very small model, and the answer is correct. So this is how simple it is to use the Amazon Bedrock Marketplace. And now I hand over to Martin to talk about the Dynatrace use case.
Thank you, Simone. So now I will show you how we at Dynatrace select the models for our product. At Dynatrace, what we do is we observe, we optimize, and we analyze And specifically, we do that for our customers and for their specific offerings, typically a cloud-based web application. And when I say all aspects, it means infrastructure, application, the user experience, security, business analytics, and much more. And what makes us really special is that we do all this on a unified platform, so you can combine all these different sources and derive insights from that. It's fully automated, or you can fully automate it, and of course, it's powered by AI, one of the reasons why I'm standing here today. At Dynatrace, we take AI very seriously. In fact, we have implemented it into our product even before it became as sexy as it is today. We have at least 3 different pillars of AI in our product. Predictive AI, which is essentially classical machine learning to do forecasting, anomaly prediction. Then causal AI. The point here is if something goes wrong, if the website doesn't work, to understand what is the root cause, for example, a database that is not responsive. And the most recent addition, generative AI, which gives our customers a natural language window into the product. Let's see what I mean with that. It means the user enters with some text in whatever their language is, can be English, can be any other, and then can get out something. That something can be information in like chat. We are all very familiar with that by now. Can also be something maybe slightly more interesting, like a query. In our Dynatrace query language, you can use natural language in workflows. You can use it to derive insights specifically into your data, so not just generic product information. And in the future, possibilities are almost unlimited. At some point, for sure, you will be able to generate a whole dashboard with just a simple prompt, 1 or 2 sentences. Let's have a closer look at the 2 use cases that are most important at the moment, chat and query generation. For chat, the main method that we rely on is retrieval augmented generation. So those of you familiar with that know that the model skill that is most relevant in that case is, on the one hand, language understanding, on the other hand, summarization. Both of these skills, all of the modern foundation models really know very well. So here it's an obvious choice to go with a foundation model. On the other hand, for query generation, we rely heavily on context engineering because we have to provide a lot of information to the model. So domain knowledge is what we mostly base it then on. In this particular case, knowledge about our query language. And since, foundation models know it to some degree, but they are not specialists in that, obviously. So here it made sense for us to go with a fine-tuned custom model. And I will say more about that later in the talk, but let's first stay with the foundation model. So even in the first case, foundation model surely does the job, but still, are there other options? Why would you choose a foundation model over maybe a small, efficient model that you have fine-tuned for your case? There are at least, I think, 3 reasons why you would be doing that. One is faster innovation. You can get started immediately without developing your own models, but also when you update, if a new foundation model comes out, you just switch. If you need to retrain your own model, that requires, of course, a lot more time. Compliance is often an overlooked aspect of this. If you produce your own model, you need to certify it. You need to convince your customers that it's compliant. You need to answer lots of user questions each time you get in touch with them. If you can point to a foundation model that is already out there on AWS, for example, compliant, certified, it makes the job a lot easier. Lastly, you save costs. Very obviously, when developing the model, you don't need to do that. But even for inference, very often it's cheaper to just query one of these via API compared to deploying, hosting, and then querying your own model. Yeah. But still, now you decided you want to go with a foundation model. Today on Hugging Face, almost 1 million large language models are available. How can you even start to choose one of them? And that brings me to the triangle that Simone has already shown to you of cost, speed, and quality of responses. And I think what's very relevant is different aspects here are important for different use cases. If you look at our RAG use case, all the models can do that well. Quality is not so much of an issue. So speed and cost matter most. If you have some high-value task like reasoning, here the name already implies it, the value is anyway much higher than any cost that could be associated with that by definition. then what you would mostly want to focus on is the quality of the responses. For agentic use cases, it's twofold. You want a very strong LLM at the center that plans, reasons, self-reflects. At the same time, the agent may call 10 or 20 times within one workflow another LLM for a much smaller task. And then you want it to be quick, because if you have 10 tasks which are all slow, the user experience will be very bad. Yeah, and with that, back to Simone, will tell us about evaluation.
Fantastic. So in the previous step, you have identified 3 to 5 candidate models that fit your use case. Now, in the evaluate step, you will compare them, and the goal here is to find the one model that you want to use. So a best practice when evaluating models is to use your own data. And the reason is that different models behave differently on different use cases. And public benchmarks cannot capture these variations. Therefore, in this step, you will create your own test dataset to identify the best performing model for your use case. For example, let's assume you are a retail company and you want to create an AI-based marketing campaign. What you will do here, you will create a test dataset using your historical marketing data and customer data, and then you will let each model generate a different marketing campaign, and then you will evaluate those marketing campaigns on well-defined metrics, such as the message relevance or the conversion rate. Now, you can do this in Amazon Bedrock Model Evaluation, which provides 3 ways for you to evaluate your models. The first one is programmatic evaluation. This is the easiest and quickest way to evaluate models, where Bedrock uses 3 different algorithms, accuracy, robustness, and toxicity, to simply evaluate your models on your tasks. And then, if you want to bring in a human touch on the evaluation of the models, you can use human evaluation. Here you have human experts that rate the quality of responses on multiple aspects, including creativity, style, tone, and you can even define your own custom tasks that human experts can use to evaluate, for example, using thumb up and thumb down. And then LLM as a judge. So this brings human-like evaluation, but you don't have a human. You have a second LLM, known as the judge, that rates the responses of the main LLM. And LLM as a judge brings, as I mentioned, human-like evaluation at 98% lower cost than human evaluation, reducing the time it takes to evaluate from weeks to hours. Now, again, the best way to look at evaluations is through a demo. So here, let's assume that you are a tourism agency for the canton Basel-Land, and you want to evaluate different models about how well they know your canton. Let's do that. I'm in the Bedrock console, and from the left menu, I choose Evaluations. Here, I want to evaluate a model in a programmatic way, so I pick Create, and under Automatic, I choose Programmatic. So I want to do the most simple evaluation. Here, I need to enter a name for my evaluation, and I enter Basel-Land Knowledge Micro, because I want to evaluate how good the model Nova Micro is on knowledge of the Basel-Land Swiss canton. Then I pick the model to evaluate, which is Amazon Nova Micro. And then I choose the task to evaluate the model on. This is questions and answers, because I want to see how good it answers. And then I need to pick metrics. And here I choose accuracy and robustness. Okay, then I need to provide a data set. And the easiest way would be to use the built-in data sets. But in this case, I want to bring my own data sets, because I have a very specific use case, knowledge of the canton. So I prepared already a set of questions about the canton that I have pre-uploaded on Amazon S3. And here I'm pointing the model to the location of these questions. So let's look into the questions. As you see, the questions are all related to the canton. For example, the year when the canton was created, the language in the canton, the highest peak, the capital, and so on. And together with the questions, I also provide reference answers. Then what Amazon Bedrock Model Evaluation will do, it will provide these questions to the model, and the responses from the model will be compared with the reference answers to evaluate accuracy, robustness, and potentially other metrics. So the list here is around 100 questions that I'm using for this specific evaluation. Okay, moving on. Here I need to provide a location in Amazon S3 where output metrics will be stored. And then I pick a role. And then I choose create to initiate the evaluation job. Okay, so the evaluation will take some time. And after some time, it will move from in progress to complete. As you can see here, I have two different evaluations. One is the one for Amazon Nova Micro that I just set up together with you. And the second one is for Amazon Nova Premier. So Nova Micro is the fastest model in the family, while Nova Premier is the most intelligent and most knowledgeable. Let's see how they compare in the evaluation. On the left, I have Nova Micro, and on the right, I have Nova Premier. As you see, Nova Premier has a better score for both accuracy and also robustness, meaning that the model performs better in this specific task of knowledge about this canton Basel-Land. All right, with that said, Martin will now talk about model evaluation at Dynatrace.
Thank you. So let's have a look at how we at Dynatrace in practice do evaluation of our models. And I will focus here on this RAG use case that I've shown before. So looking again at this triangle, the first and probably easiest dimension is speed. So what we care mostly about is end-to-end speed. How long does it take from the customer to ask the question until they get the reply to that question? And yeah, you can see the metric, it's fairly clear what we want to measure, and you can see there are significant differences. RAG use cases have a relatively long input prompt, which means it takes more time to process it than typically. And you can see significant differences, more than a factor of 2, between models which have similar capabilities in this case. Yeah, slightly more tricky is evaluating the quality of the responses. So here, for the RAG use case, there are two aspects. One is retrieval. So in what fraction of the cases do we find the correct documents to serve to the LLM to actually be able to answer the user question? So all these metrics here measure that. Here we compare our previous solution with now Amazon Bedrock knowledge bases, and you can see for all of these metrics, there's a significant improvement. Apart from retrieval, what we of course also care about is then the final answer. Here we use LLM as a judge, as Simone has already introduced to you. And there's lots of metrics. I could spend a lot of time on that, but let's just look at one of them, factual correctness. So that measures how many of the facts in the reference, in the ground truth, are also present in the answer that the model generates. And yeah, you can see again, all of the models are doing quite well, but still there are quite significant differences actually. So summing this up a bit, for all models, what's really important is that you evaluate on your use case and also on your data, because it makes a difference. Just trusting benchmark doesn't get you very far. For example, as I said, for the RAG use case, you want to know how it performs with very long prompts. What I have not talked about is if you have a custom model, then in addition, you might also need very custom metrics. And I will not dive very deeply into that here, but if you look at our query generation use case, here we have a lot of these custom metrics. One of them is this data source confusion, which is shown here. It shows you in how many cases the query refers to the correct data source that should be there according to the ground truth. Yeah, I can see it's working pretty well, but what's the important message here is this is very specific to how we at Dynatrace store the data, a very custom metric. All right, and now Simone will tell you about optimization.
Fantastic. So you now have your own, preferred model, and in this third step, optimize, you will tune this model for production. As suggested by Martin, this step is optional because you don't always need to tune models. It's only for specific use cases. Now, Amazon Bedrock provides 3 ways that you can use to customize your models. The first one is model distillation, where you have a teacher model, which is a large model, and you transfer knowledge from this model to a smaller model, known as the student. The second method is fine-tuning, where you basically tune a specific model on specific tasks or specific knowledge. And then the third one, I would say the most complex, is continued pre-training, where you train a model from scratch using vast amount of unlabeled data. Now, I will talk about distillation, while Martin will later explain fine-tuning at Dynatrace. Okay, model distillation. As mentioned, this is the process where you have a large model, known as the teacher, and you want to transfer knowledge from this model on a very focused task to a smaller model known as the student. The goal is to have a smaller model which is very fast, very cost-effective, and also has high accuracy that learn from the teacher model. So how does distillation work? It's a three-steps process. First, you define a set of prompts on a specific use case. Second, you pass these prompts to the teacher model, and you get the teacher model generate responses. And third, you pass these responses to the student model to fine-tune it. And as a result, these still models are up to 500% faster and up to 75% less expensive than the original teacher models, with less than 2% accuracy loss on very focused use cases. Now, in Amazon Bedrock, you have two ways to do model distillation. The first one is using your production data. The way it works is that you already have your teacher model in production, and you enable invocation logging on the teacher model so that the prompts are saved in your Amazon S3 bucket. And then you create a distillation job that points to those production prompts in Amazon S3, and the distillation job will use the prompts to generate responses from the teacher model and responses to fine-tune the student. The second way, you just provide your own prompts. So it's very simple. You need to provide a set of prompts, minimum 100, but ideally many more. And these prompts, again, will be used by the teacher model to generate responses and responses to fine-tune the small model. Okay, once more, the best way to see this is through a demo. So the use case is the same that you had before. So let's assume that you are, again, a tourism agency for the Swiss canton Basel-Land, and now you want to build a virtual assistant that helps tourists find activities and information about your canton. So you want this virtual assistant to be very fast and cost-effective, therefore you choose model distillation. So to do so, I'm in the Amazon Bedrock console, and I choose Custom Models on the left menu. Then I choose Create to start distillation, and I choose Create Model with Distillation. Here, I need to enter the name of my distill model, and I will call it Canton Basel-Land Tourist Guide Model. That's basically what the model will do. Okay, then I need to choose the teacher and the student model. So as a teacher, I will pick Amazon Nova Premier. If you remember, it was the big model that performed best in the previous task. And I want to take knowledge from this model. And as a student, I will take Amazon Nova Micro, which is this fastest model and most cost-effective model in the family. Okay, then I need to provide a location on S3 with the prompts for fine-tuning, and I pre-uploaded them. Let's take a look at those prompts. So these prompts, they are basically all questions related to the Basel-Land canton. For example, what is the history of the canton? What are some locations to swim? Or what are some markets where I can chill? So these are basically all questions related to the canton that I want to be answered by the teacher model, and then the knowledge transfer to the distill model. Okay, moving on, I need to enter a location for the output matrix of the distillation job. I need to pick a role, and then I choose Create Job to initiate the distillation process. Okay, this will also take some time, but after some time it will move from in progress to complete, meaning that now I have a distill model that I can use. To use it, I choose a setup model for inference, and then I choose on-demand inference. This way, I will be able to chat on demand with my distill model. Here, I enter a name for my deployment. I will call it Canton Basel-Land Tourist Guide. This is the name of my chatbot. And then I choose Create to create the inference endpoint. All right, this is now active, meaning that I can now chat with my distill model. Let's select it, and let's choose Test in Playground. Okay, now let's ask a question to the model. What is the highest peak in Canton Basel-Land, and what can I do there? Okay, as you can see, the distill model will answer in a very fast way, because it's a small model, and also in a very accurate way, because it took the knowledge from the larger teacher model. Okay, let's now do something even more interesting. Let's compare the performance of the distill model on the left with the performance of the teacher model, Amazon Nova Premier, on the right. Okay, I will ask both models the same question, and let's see what happens. So as you can see, the distill model on the left is answering much faster than the teacher model on the right, the answer is very similar because of the distillation process. However, the distill model took only 5 seconds to answer, while the original teacher model took around 10 seconds. So this basically shows the power of distillation, where you get good cost and speed, and also very high accuracy on specific use cases. And now back to Martin to talk about fine-tuning at Dynatrace.
Thank you, Simone. Yeah, so as you have heard, there are various methods how you can customize your model. Simone has already shown you some of them. I'll just briefly summarize the most important ones that we considered. The first one is context engineering. So here you start with a foundation model. Then you add a lot of specific information into your prompt. And you end up still with the same model, of course, so a very general model with at least some domain knowledge, however much you can fit into the prompt. Second method we've just seen, distillation. Start with a big foundation model, end up with a small model. Small means it's efficient, but it's still very general in its capabilities and knowledge. This is something you may or may not want for your use case, right? Fine-tuning, you already start out with a small model, end up, of course, also with a small model. So you're still very efficient, but it's very domain and very task-specific. Again, something you may or may not want for your use case. In our case, this is exactly what we wanted for query generation, because we want the model to do exactly that well, generate a query and nothing else. So what do we actually mean with query generation? I still owe you that. The user comes in with natural language as usual. For example, create a time series of memory usage, and the model then generates a query in our Dynatrace query language. You can see what it looks like here. This is still a fairly simple example. Still, it requires quite some knowledge about words, about your data, and so on. So even if you're an expert user, it might take you a few minutes to create that. If you're not an expert user, maybe you cannot do it at all. But our model does it for you in a couple of seconds. Now, what do you need to do in order to be able to generate such a query that you've seen? What do you need to know? What kind of skills do you need to have? It's, in many cases, very complex. Leads some people to believe it's actually magic, which, of course, is not true. What you actually need is still quite a lot. You need to know about language, and you need to know about data. So language-wise, you need to know about grammar. For a query, you would call it syntax, probably. You need to know about vocabulary, so about names for commands, functions, and so on. On the data side, you need to know what are the sources of your data, what are the objects there, what are the relations, semantics, and so on. So you see, it's quite a lot of stuff that you need to know. And of course, if you don't give this information to your AI, then you cannot expect it to generate a query. So you need to deliver that first to even have a hope of succeeding. Let's have a look at how we did that. Our first approach, the earliest one, was to use a foundation model. So here, user comes in with some natural language inputs. An LLM foundation model decides if this is related to DQL at all. If not, we refuse to answer. Otherwise, we continue. Second step, we plan how to generate the query. So here we pull in some context specific to the user question about DQL commands, about the data of the customer, and the output is then a plan. And in the third step, we again call the LLM, this time again with a lot of context on user data, DQL comments, but also this plan and relevant examples, few short examples. And then the LLM replies with the query eventually. We verify that this query is actually executable, that it's valid, and if yes, then we present it to the user. So if you think this is complex, then you're of course absolutely right. That's why we came up also with our second generation, and that now looks a lot simpler, like that. Just one step, question in, answer out, essentially. And the way we achieved it is that by using a custom model that was specifically trained to generate DQL queries, which means we don't need to teach it DQL from scratch again each time we call it. We still need to provide some context about the user data because, of course, we don't train on user data, and even if we wanted to, we only have a picture of the past and not of the present, right? And as a side effect for user experience, apart from a much better quality, it's also about a factor 2 faster. How do we do this fine-tuning? Nothing very fancy about it. The most important part, as usual, is data, collecting data in high quality and high quantity. We do that by simply getting queries that within Dynatrace our employees use every day. Then we massage that data, means we generate a prompt that fits to the query using an LLM. We do a lot of processing, quality assurance, and so on. That would be a talk on its own. Then we use it to fine-tune a model. The model that we use here is a 7 billion parameter model. We use efficient fine-tuning, meaning that we can use just a single GPU, not even one of the fancy ones, but an older version, an A10, and can eventually do a training run for about $30. So it's really super cheap then in the end to train the model. Right, then next we evaluate the model. If needed, we create a new test set for that. And if the evaluation gives green light, if the new model is better than the old model, then we deploy it to AWS Bedrock. So that's the training side. Then on inference side, I've already shown you this, but I want to point out two, I think, very interesting aspects. One is this putting in context from the user data and giving that to the LLM. That helps us if, for example, the user asks, show me errors of my app. Without additional context, how would you answer that? It's not possible, of course. But from the user data, we know that the app of that user is called, in this case, Easy Travel, and we can actually generate the correct query. The other aspect is this verification step. In some cases, the model generates a query that is not actually valid. If that happens, like in this example here, we immediately notice it cannot be executed. And what we then do, we remove the part that is incorrect, and we use our autocomplete that anyway exists in Dynatrace for DQL. We use that to fill in something plausible for the query and to finalize it. And in that way, we are then able to, in almost all cases, present a valid query to the customer. All right, bringing us all back to this triangle. How did we now try to address all these different aspects with our model? Concerning the quality, the most important aspect here is data, quality and quantity. But by having this very domain-specific model, we are also particularly good at this one task better than anything else and can provide high quality to our customers. Concerning costs, it's cheap because the model is small. The prompt is short, fewer tokens means fewer dollars again, and also using the serverless Bedrock deployment. So in the end, as I said, $30 per training, even cheaper than DeepSeek R1. Regarding speed, it's all the same advantages, small model, short prompt, and the Bedrock deployment, which also make it fast, in the end about 2 times faster than when we were using a foundation model at the first iteration. Okay, and with that, back to Simone to wrap it all up.
Amazing. Martin, very incredible story with a lot of learnings and best practices. Okay, we are now moving towards the end of the session, and to sum it up, today you learned about the model selection framework with 3 steps: identification of candidate models, evaluation to find the best model, and then optionally optimization to tune your model for production. However, one final consideration: this framework can and should be used in an iterative manner. For example, after optimizing your model, you can go back to evaluation. For example, as Martin mentioned, at Dynatrace, after fine-tuning their model for DQL, they go back and they evaluate the performance of the fine-tuned model. Or, after optimization, constantly go back to the identification phase from time to time. Maybe because your use case changed or because new models were released on the market, you want to make sure that you stay at the forefront of the technology. All right, and with that said, we are really closing. Here you can find a QR code with some resources about what we discussed today. If you scan it, you will find a page with blog posts about model choice, evaluation, fine-tuning, distillation, custom model import that Martin quickly talked about, and also articles about the Dynatrace experience and story with AWS. All right, I will give some more time to scan this. And with that said, someone wanted, I think. Okay. All right. So, and with that said, we really thank you very much for your time today. Don't forget to scan the QR code here and to fill in the session survey. We really appreciate your feedback. And other than that, we really wish you a good rest of the summit. And for any question, you can reach out to me or Martin. We are here below the stage for any question. Thank you again, and enjoy the summit.
Thank you.